Continuing on with week 1 of classes, and I believe this is video 8 in vibrations. So from experimental data, UHeart students determined that a diving board in the Reich family center vibrates sinusally. They measure an amplitude of 15 centimeters. Let's see if I can come back up here. 15 centimeters in a period of 2.25 seconds. So this is pretty good because it's similar to real life, right? That you could maybe with a camera, maybe with a slow speed camera and some kind of reference, be able to measure the amplitude of the diving board, and then with a stopwatch or with using the video of a camera, figure out what the time stamp was to figure out what the period was. So it is possible that you could do that. So we wanted, by the way, this is also one of Dr. Bob Selmer's examples. So let's see, his amplitude is 15 centimeters, and its period is 2.25 seconds. Right. So one of the first things I would do, I would say that this is its natural period. So we'd have our natural frequency is 1 over the natural period right there. So 1 over 2.25. So these are pretty low frequency here. It looks like it's 0.4444 hertz. But remember, we want to take that and turn it into circular frequency by taking 2 times pi times Fn. And by the way, if you're ever not sure whether you divide by 2 pi or multiply by 2 pi, just remember that the units, and these are going to be 2 pi radians per second. This is just so you're about 2 pi radians per cycle is what you're multiplying this by, and this is 1 over seconds, this hertz, so that you can we need radians per second, so we must multiply by 2 pi. So 2 pi divided by, multiplied by 0.4444, and so we end up equaling 2.793 radians per second. So recall that in the simplest of relationships for this motion, this periodic motion, we have that, take the derivative of it, get x times omega n cosine omega n t, and then x double dot for acceleration, x is going to be negative omega n squared because we took the derivative of a cosine, that's why it's negative. Take a sine, negative sine. And so what is the maximum velocity? Well, it's going to be that max. It's really just going to be x times omega n. So 15 times 2.793, or 41.89 centimeters per second. There's the answer there. And x double dot max can be x omega n squared, or 15 times 2.793 squared. So the maximum is 117.0 centimeters per second squared. I'm not a big fan. I would really prefer, when you have a long problem, though, to go ahead and write out to the very end and box the answers. So just rewrite them at the end and box the thing out, so I don't have to go searching for your answer. I beg you, please. The next video is actually for a whole new section, and so I'm going to make it a new video. So this is video 8, I believe. It's too many videos, but more is better, right? So here you go. See you in the next one.